Alright guys, so today we're looking at section 2.1. So what we're going to be doing is describing transformations of just quadratic functions. Last chapter we were working with absolute value and with quadratics, and now we're going to narrow it down to just quadratics, and we're going to have a few more details to look at. So we want to be able to write transformations of quadratic functions, graph the functions, and find domain and range. The vertex of a parabola is always the lowest point if we have a parabola that opens up. So our basic parent function is y equals x squared. That parabola opens up, and what's its vertex? 0, 0. So the vertex, if a parabola opens up, is going to be this lowest point right here. If we want a parabola that opens down, I can multiply this function by -1 and make it y equals -x squared. And now we have the same parabola, except now it would open down because it's a reflection over the x-axis. And the vertex here is still 0, 0, but now the vertex is the highest point because our parabola opens down. Okay, so that would not change. To have a parabola written in vertex form, we want it written like this. F of x equals a, and then this b has to be factored out of this part of the function. Okay, it has to be factored out, and I'm going to show you that below. Then we have x minus h quantity squared plus k. A can't be 0 because if a is 0, the whole function just becomes 0. hk, circle this guys, hk, that's going to be the vertex when we have it in this form. This A is going to be a vertical stretch, B or vertical or stretch or shrink. This could be a horizontal stretch or shrink, but that's going to be a shift to the right or left. That's going to be a shift up or down. That's going to tell us our vertex. We know if we have x minus h as a replacement for x, that shifts us right. X plus h is going to shift us to the left. If it's on the outside of the parentheses, a plus k takes us up. Minus k takes us down. Let's look at this example and find all important information. This is already in vertex form. This is our h and this is our k. What do you guys think the vertex is then?
3, 4.
You got it. 3, 4 is the vertex. I'm going to set up a table of values to graph this more exact. So I'm going to put 3, 4 in the middle. I'm going to go up 2 and down 2. This is going to give me other points very close to the vertex. See how it says to find 4 other points. So I'm going to plug in 4. 4 minus 3 is 1. 1 squared is 1. -1 plus 4 is what? 3. Now, because of the symmetry of the function, this point here we just said was 4, 3. What do you think 2 is going to give us? If you don't know, then let's do it. What's 2 minus 3? -1, square it. Multiply it by a negative. Plus 4. We just kind of wasted time. If we would have known that those 2 points were the same, we could have saved ourselves some time. Plug in 5. 5 minus 3. Square it. Times a negative. Plus 4. Good. What do you think this point's going to be? 0. You can do it if you want. 1 minus 3 is -2. -2 squared is 4. -4 plus 4, 0. Plot the points. So now we've got our point of 1, 0, and 2, 3, and 5, 0. Here's the way the parabola looks. Right there. 4 other points, I'm just going to put an asterisk. They're over here if we want to see them. The domain of this function is going to be all real numbers. How do I write that in interval notation? -infinity to infinity. The range is the y values we can use. These y values go all the way down here, up to this point. What's the range? Good. Intervals of increase, this is new. This function is increasing until it gets to our vertex. Our vertex is right here at 3, 4. So we're talking about the x values that cause the function to go up. The x values that cause the function to go up are those x values to the left of x equals 3. All the x's to the left of x equals 3 are causing the function to go up. Here's how I write that. Negative infinity to 3. The x values of negative infinity to 3 are causing the function to increase. What x values are causing the function to decrease then? The ones to the right of x equals 3. What are those going to be then? All the numbers larger than 3. 3 to what? Infinity. Those are the x's that are causing the function to decrease. Why do you think we don't use a bracket around the 3? We don't include it, but why wouldn't we include it? I'm talking about all the points that are causing the function to increase, and then all the points that are causing the function to decrease. What's happening at 3? Is it increasing or decreasing? Neither. It's not changing at all, right? That's the reason we don't include it. If I wanted to check my table of values, just a reminder that you can go under y equals. You don't need to follow along on this, but I just want to show you with this table how nice it is that we can check all these values that we came up with. So I can put these all in, and then I can just go to my table, and I can see my points, 1, 0, 2, 3, 3, 4, 4, 3, and 5, 0. I know I'm correct. Okay, number 2, we're not going to do as much with this one. It just says to describe the transformation from the parent function. Then state the vertex. Check on the graphing calculator. Guys, when you first look at this, what do you think the x-coordinate of the vertex might be? Yeah, feels like it should be -6 maybe. But let's put this into the calculator. I'm going to put it in. Parentheses 3x plus 6 squared minus 1. And I'm going to graph it. Is that vertex at -6? No. So what do you think the issue is then? Yeah.
You have to factor out the 3.
All right, so Ian, what would I get then if I did factor out the 3?
You would get parentheses 3 and then parentheses x plus 6.
So if I take the 3 out of the x, I also have to factor it out of the 6. So x plus 2, parentheses, parentheses squared, then minus 1. Now this function is in our vertex form. See, look at this vertex form again. It says we have to have parentheses b, parentheses, nothing in front of the x, minus h squared. That's what we have now. This is now in vertex form. So what should the vertex be based on this vertex form that we have? -2, -1, right? And if I look at the table, I can see how -2, -1 is that lowest point? So that is the vertex. So what is this 3 actually doing? It's a horizontal what? Good job. Horizontal shrink of what? 1/3. Good. So this function had a horizontal shrink of 1/3. Then it also got shifted what? What does this do? Shifts us to the left 2. And then what did this do? Took us down 1. All right? So you have to be careful. You can now see why that actually is a horizontal shrink. It could also be called a vertical something though. Because this is now multiplication, I could actually compute this 3 squared. I would be allowed to do that. I could rewrite this function. This is kind of advanced. I hope this doesn't confuse you. But I could actually rewrite this function this way, and it would be exactly the same function. Let me show you. I think this is so interesting. This was our original function. First, we said this was equivalent. Right? That was the first one that we said is equivalent. We factored that 3 out. Watch. There's the blue one. Here comes the one we said was another name for it, right? This one. Now I'm saying that this one's equivalent. Let's check it and see. So now I come down here and I'm going to put in 9 parentheses x plus 2 squared minus 1. Graph that one. See how it is exactly the same? So why is that? Why is this and this, why are they the same? What did I do? I squared the 3, right? I didn't square this, so this is still getting squared, but I went ahead and squared the 3. So let's just stick with this, but what else could I call it? A horizontal shrink of 1/3 or a vertical what? Stretch of 9. I could call it that too. All right, let's go over here. This is all review. I'm going to go through it quickly. To have a reflection in the x-axis, we multiply the whole function by -1. That flips us over the x-axis. To have a reflection in the y-axis, we replace the x with a negative x. Now, if I reflect a parabola over the y-axis, does it really change it? No. So it just turns into the same thing, and that's because a negative squared is just a positive x squared. All right, horizontal stretches and shrinks. If I want a horizontal stretch of, I hate when they write it like that. That's not right. We're not writing it that way. If I want a horizontal stretch of, say, 2, what would I replace x with to have a horizontal stretch of 2? 1/2, right. So if I start with f equals x squared, I want a horizontal stretch of 2, I would have to do g equals 1/2 x quantity squared, okay? If I want a vertical stretch, then I want a to be greater than 1, and that's going to cause that vertical stretch, and this is the whole function, okay? All right, we already know all that. Let's just review, like I said. Describe the transformation of the graph of the parent function. So the parent function is f equals x squared. We are looking at g of x equals -2 x minus 3 squared minus 4. The first thing I want you to get in the habit of doing is stating the vertex. Check it. Is it in vertex form? In front of the x, we just have a coefficient of 1 inside the parentheses. That's good. So what's the vertex going to be, everybody? 3, -4. Do y'all agree? Yes, that is correct. Okay, so we've got the vertex. Now, what is this this negative going to do? Right, so reflect over x-axis. Then what's the 2 do in the front? Vertical what? Vertical stretch of 2. Also, what else? We went to the what? Right 3. And what else? Down 4. Okay, that's all the transformations. If we wanted to do a quick graph of that, I would go to 3, -4. I'm not going to find all the points and everything. I know I reflected over the x-axis, so instead of going up, it goes down. And I actually know those first points are going to have to be down 2/1. That pattern does not keep continuing, but it does help us to find those first couple points. Okay? If I wanted to know these points, I'd want to make that table of values. Okay? There's our parabola. All right. Looking at this, if we're given a function, this is our regular function of just y equals f is what we call it. What if we now have the function y equals f of x plus 3? What does replacing x with x plus 3 do to the function? Shifts it what? left 3. Good. It's just a different notation. So all I would do is take that point to the left 3. Where is that now? It's at 3, -1. So now it would be at 0, -1. And it would be that same parabola shape. We're just doing kind of an estimate here. And what kind of function would this do? If I have my function and I have -2, what's that do to us? Takes us down 2. So where would my vertex turn to now if I took this function down to? Good, 3, -30. And I would have that same shape. All right, just real quick graph. Okay, describe the transformation of f of x equals x squared if we go to negative of the quantity 3x squared plus 2. I want you to think about this for a minute on your own, and then we'll talk about it. There should be 3 things that happen. And just go in the order that they occur. Okay, guys, so what does the negative out in front do? Reflects over what? Okay, what does replacing the x with a 3x do? Be careful with that. Replacing the x with the 3x. What is it? Good. And then what's this do? It takes us up 2. And if we wanted to, I could check this. Just showing you real quick how, if you're taking the test and you feel like you're not confident, or even if you're just like doing homework and you're just not sure if you did it right, you can go ahead and graph this. Use your graphing calculator. I'm telling you, the more you practice with it, the better off you're going to be. Here's the original. Here's the new one. And we should see that all those things happen. First, it got reflected over the x-axis. We had that horizontal shrink of 1/3, and then it's up 2. See how we can see that we did all that correct. All right. Write a rule for G described by the transformation of the graph of f. Then identify the vertex. Our function is x squared. We want a vertical stretch by a factor of 3, a reflection in the y-axis, followed by a translation 4 units left. All right, step 1. Omar, how do I get a vertical stretch by a factor of 3? What do you guys think? First he said multiply the x by 3. Multiply what? The entire equation. So this entire equation for my first step is that the entire equation gets multiplied by 3. That makes it like this. It's not a replacement, it's a multiplying the whole function. Okay, next, that was step 1. I'm going to mark it out. Reflection in the y-axis. Does anyone know what I do for that reflection in the y-axis? Yep. What do we do, Finn? All right, so you're saying for that, I'm going to have to do 3, and then on the inside, negative x squared. That is correct. That's what's going to give me a reflection in the y-axis. Now, I could stick with this, but I don't really want to because of what I have to do next. When I look ahead, and I'm going to have to go 4 units left, that's going to be a replacement of x, and that's going to be pretty complicated. But I can write this in a much easier way. How can I rewrite this just to make it an easy function? What is negative x squared? And just positive x squared, right? So what's another name for this function then? Just 3x squared. Remember how if we reflect over the y-axis, it really doesn't change the function? That's why this really didn't change, did it? Think, I do that vertical stretch, but then I flip it, it's still just the same thing. All right, so I did that. Number 3, translation 4 units left. This is where people mess up. If I want to go 4 units left, I want you to think about what you think this final function should be. Anybody think they know? Emily, you look confident. What do you think? It's okay. Okay, is it 3x squared plus 4? Is that going to take us 4 units left? What would that do? That would take us what? 4 units up. Okay. Okay, go ahead. She's going to try again. You got it. That's right. That's going to take us 4 units left. Okay? Now, you know, like if I would have given her some time, like she could have looked at this and put in 3x squared plus 4, and she could have said, okay, did that shift that function 4 units left? Did it? No. So then we try some other things, and then we could check her 3 parentheses x plus 4 squared and see if that shifted us 4 units left. Did that do it? Yeah. All right, you guys try this one now. Instead of going 2 units down, I want you to go 5 units down. Where it says translation 2 units down, let's make it 5 units down. Oh, I forgot to identify the vertex. The last one, the vertex is negative 4, 0. Guys, go back up here. I'm sorry. I forgot to put the vertex on these. What's the vertex on this one? 0, 2. Good. And this one was negative 4, 0. And also, guys, order matters on these. Like, you have to go in the order that it tells you to. All right, I know you may not be finished, but I'm going to walk you through this now, and we'll see if you were thinking in the right direction. Here's my function f. If I want to do a horizontal stretch by a factor of 3, that means that I have to take my function and I have to replace x with a 1/3 x. And that would give me 4, and then in parentheses, 1/3 x, then squared minus 2. That's step number 1. I haven't done that yet. I'm also going to go ahead and simplify this. Guys, if this is multiplication, I am allowed to just square this and square that. If it's addition, I am not. Look, guys, if I have x plus 1 squared, that is not x squared plus 1. I can't just square that and square that. I would actually have to write it like this, and I'd have to FOIL it all out. It's actually x squared plus 2x plus 1. I would never have you square it out if it's plus or minus in between it. But if it's multiplication like this one, you could just go ahead and square this and square that. Does anybody do this and write it as 4 times 1/9 x squared and then minus 2, which would be 4/9 x squared minus 2? You could have this function, or you could have this function for that first step. I'll just stick with this. Is this what you guys all did? Okay, I'll just stick with this then. Next, we want a translation 5 units down. So what would I now do to this function? Subtract 5 from the whole thing, right? So I'm going to take this whole function and I'm going to subtract 5 from it. So it's going to be 4 times 1/3 x squared minus 7. Or I'm going to say some people did this. Or it could have been 4/9 x squared minus 7. Like that. Either this or this. The last thing I have to do is a translation 1 unit right. That's the third step. That's why I have the 3. First step, second step, third step. If I want to go 1 unit right, that means this doesn't change, but wherever I have an x, I have to replace that x with x minus 1. This gets tricky. Circle the x. That stays the same. That stays the same. This x has to get replaced with x minus 1, then squared, then minus 7. That's like the most difficult problem you would see of that type. There it is. If you did it this way, you would have gotten this. I think it's easier to work with in this form, but if you forget to do it, then you're stuck with that. But look, guys, hey guys, just watch one real quick. See how this is multiplication? So I would be allowed to go ahead and square the 1/3. What's 1/3 squared? Square the 1, square the 3. What is it? 1/9. And then I can multiply it by that 4 and get 4/9. But this one, I don't really want to multiply out, so I keep it like that. Okay? All right. That's good. So you guys need to do that assignment, if you haven't already, page 52 through 54, all those problems that are on Canvas for you.